Welcome back to the channel. Today we are diving into one of the most elegant binary tree problem you'll encounter in interviews, the symmetric tree problem. Symmetry is everywhere in nature, but can we detect it in a binary tree? Stick around because by the end of this video you'll solve it like a pro. I first encountered this problem while prepping for a technical interview. At first I thought symmetry easy, but trust me, once you dive into recursive solution it gets a little tricky. That's why I'm here to make it crystal clear for you. Here's the plan. We'll solve this with a recursive approach. The idea is to compare two subtrees at a time and check if they are mirror image of each other. Let's jump into the code and write this step by step. I'll explain every line, so don't worry. If you're new to recursion, it will all make sense. Alright, let's start with the solution class and a IsSymmetric method. This is the entry point of our symmetry check. First, we have this method. Let's break it down line by line. This method takes in the root node of the binary tree and returns a boolean indicating whether the tree is symmetric or not. Here we are handling the edge case. If the root is null, the tree is empty, and an empty tree is always symmetric. Now we are calling the IsMirror helper function, passing in the left and right subtrees of the root. This is where the real comparison happens. Next, we have the IsMirror method, which does the heavy lifting. This method takes two nodes, T1 and T2, and checks if they are mirror images of each other. If both nodes are null, they are symmetric by definition, so we return true. If one of the nodes is null while the other isn't, the symmetric breaks and we return false. Here we are checking if the value of the two nodes match. If they don't, the tree is asymmetric and we return false again. Finally, we recursively check the left subtree of T1 against the right subtree of T2 and the right subtree of T1 against the left subtree of T2. This ensures that every level of tree mirrors perfectly. Now, let's look at the tree node class, which defines the structure of each node in our binary tree. Here's what's happening. This is the blueprint of each node in our binary tree. We define three fields: val for the vals node, and the left and right for pointers to its left and right children. This is the constructor which lets us quickly create new nodes by passing in a value and an optional left and right children. Simple and efficient. Finally, let's test our solution with two examples. Here, we are building a symmetric tree with a root node of value 1 and its left and right subtree mirrors each other. When we run IsSymmetric on this tree, we get true as expected. In the second case, we are building an asymmetric tree. The left and right subtree don't mirror each other, so the output is false. And there you have it. The symmetric tree problem isn't just a great way of practicing recursion, it's also common interview question. My advice, practice it and remember, recursion is your best friend here. If you have enjoyed this breakdown, smash that like button and drop a comment if you have any questions or coding challenges for me. Until next time, happy coding.